Okay, so today we're going to talk about multiplying polynomials. The last class we talked about adding and subtracting polynomials, and you'll see some of our vocabulary coming into play here. So the first thing we're going to look at is when we multiply a monomial by a polynomial, which means one term that gets multiplied by many terms. And it says, remember properties of exponents. So when we learned about our multiplication properties of exponents, when I multiply and we have exponents involved, we're adding those exponents together. Okay, so really all we're doing here is distributing. But along with that, we're going to have integer coefficients and we're going to have variables with exponents. And we need to think about those kind of separately. So for the integer coefficients, 4 times 3, that's 12. So we, just like it's always been. And the x squared times x to the first would give me x cubed, adding exponents there. And then multiplying 4x squared by 5, well, 4 times 5 is 20, and then that x squared doesn't have anything to kind of combine with it. It's just going to say 20x squared. There's my first multiplying of a monomial by a polynomial. Let's look at the one below that. So a lot more going on here. We have to be really careful about that negative in front of my integer. So this negative 8m cubed is going to distribute through to all of these terms. And for my coefficients, I'm multiplying as always. And for my variables, I'm using properties of exponents. So negative 8 times 4 is negative 32. M cubed, adding exponents m to the 6. Negative 8 times negative 3, negative times a negative is going to make that positive 24 for the coefficient. M cubed, m squared, adding gives me m to the 5th. Negative 8 times 2 is going to make negative 16 for the coefficient here. M cubed times m to the 1st is m to the 4th. Negative 8 times negative 1 gives me positive 8. And I have m cubed, nothing to combine with that m cubed for that last term. And here's my in standard form result of multiplying this single term, this monomial, by the polynomial. So now I would like for you to try this, just monomial by polynomial, just these two, don't go beyond that, on your own. Okay, so now check your answers on these two problems. Again, adding exponents up and multiplying our coefficients. Now, when we multiply two polynomials, so now getting away from just distributing a single term, okay, really, we're doing the exact same thing. It's just we need to distribute more than once. So here I have a binomial times a binomial. I'm going to start here. First, I'm going to distribute x through. I'm going to take x and I'm going to multiply it by the two terms in my second parentheses, which would give me 2x squared and 3x. Now I'm going to take negative 4 and I'll distribute that as well to both of these terms. Negative 4 times 2x gives me negative 8x. Look how I line this up. And then negative 4 times 3 gives me negative 12. So I lined it up so that my like terms are easy to combine afterwards. And I'm just going to add anything that can be combined, should add those like terms together. And here's my final answer, standard form. Okay. But because I distributed x and then distributed 4 and I ended up with like terms, I want to combine that before having my final result here. So now I'm actually going to skip down to here. You need to kind of be strategic on what you're distributing. So I chose to distribute these two terms. It wouldn't have mattered. I could have also taken 2x and distributed that, and 3 and distributed that. I would get the same answer. So it doesn't matter if you distribute from the left over or from the right over. And on a problem like this last one, I don't want to distribute, there's 4 terms in this first parenthesis. I don't want to distribute 4 times. So I'll choose this binomial with 2 terms. And first I'll distribute 3x to all of these terms, which would give me 3x to the fourth, adding exponents. 3 times 2 giving me 6x2 plus 1 cubed plus 12x squared plus 3x. So that's distributing 3x through to these 4 terms. And now I need to take 5 and distribute that through to all 4 terms, which 5 times x cubed is 5x cubed. I'm going to write that underneath my other x cubed term. Instead of writing a long strip of all of these terms and then having to combine them afterwards, I kind of strategically organize as I go. 5 times 2x squared is going to be 10x squared. Again, writing that underneath the other x squared term I have. 5 times 4x gives me 20x. And then 5 times 1 gives me 5. And by doing that, I've kind of, going back to addition and subtraction, created these columns. And I'm going to combine them. I'll have 3x to the fourth, 11x cubed, 22x squared, 23x, and positive 5. And there's my polynomial that I get when I multiply these two parentheses together. So now I'd like you to try here and here. And again, distributing the first term, distributing the second term. Distribute the first term, distribute the second term. Combine like we can. Okay, so on these two that I had you do on your own, you didn't have a lot to combine. On the first one, you only end up having m cubes that are going to end up combining. Here's my new polynomial. And here, things are kind of written out of order. So like when I distributed the 3, I got this. When I distributed the -1, I get here. And none of these are like terms. So it's really, they're just really going to stay their own term. And I rearranged it, which you should as well, so that it's in the standard form, largest exponent to smallest. So then the last thing we're going to talk about today is when we, and we've already done this, multiply a binomial by a binomial. I'm going to do the first example exactly how we did up above, because I don't actually, so what we're going to talk about is what's called the FOIL method. I don't actually really refer to it as the FOIL method very often at all, but it's something you may see at the middle school, or you may hear another teacher say, or another student say, and it's a method a lot of students really like and kind of stick with. So what I do when I look at a binomial times a binomial, I do exactly what we did up above. Take the first term, and I distribute that, which gives me x squared plus 5x. I take the second term, and I distribute that, which gives me 3x plus 15 here. And then I combine my terms, giving me x squared plus 8x plus 15. What many people do is they think about this distributing and think of FOIL. And FOIL stands for first, outer, inner, last. First, outer, inner, last. So instead of thinking about it as distributing, rewrite the problem. They think about it as, well, I'm going to take the first term from each parenthesis and multiply that. Then I'm going to take the outer terms, multiply that. And I'll take the inner terms, two inside terms, and multiply there. And take the last terms from both parentheses and multiply. Notice it's the exact same numbers. Okay, so it's really just getting away from thinking about distributing and instead following this pattern. I like to think about distributing because it's going to work whether it's a binomial times a binomial or if it's a binomial times a polynomial. Okay, so I kind of stick with the idea of distributing as I talk about it, but you could say, okay, first term, now let's talk here. We have two different variables. This is going to become 8x, y. We can't combine those. First, outer terms, 20x. Inner terms, those aren't going to be like terms. I'm just going to write next to each other, -6y. Last term, two terms, gives me -15. Okay, now that I'm not writing in standard form because I have more than one variable going on. I'm just writing it as it ended up. So flip this page. Let me do a couple more with you. Now I'm going to kind of pick and choose here. So I'm going to do think maybe let's just do these top two and that'll be good, and I'll let you try the bottom. So remember, really all we're doing is taking this first term and distributing it. That's giving our first outer in FOIL, which gives me 6p squared plus 14p. Then we're taking the second term of this parenthesis and distributing it, which gives us our inner terms and our last terms. So that's giving me negative 15p minus 35. Combining the middle, 6p squared, subtract p, subtract 35. Now, the next one has more than one variable, so I want to talk about what that looks like. So distributing 3t to both terms, 3t times 4t is going to give me 12t squared. 3t times 3r gives me 9, 3 times 3, but t and r are different variables, so it's just going to say tr. Now what gets confusing here is when we multiply this term through, when we distribute this term through, 4 times 4 gives me 16, and then if I go in order, it's going to be rt. Well, tr, rt, it's the same, it's just flipping around the variable order. So when I write this, I'm going to keep it consistent and say I have 14 and a t and an r. And then 4 times 3 gives me 12, r squared. Combining like terms here in the middle, those TRs, 12t squared plus 25tr plus 12r squared. And there's my result of multiplying through. So now I'd like you to try the bottom four. This, by the way, should say day 2. It says day 1 again. We're going to stop after these 4 today. Okay, so let's look at these 4. You can see my work up above, m squared plus n minus 12 for this one, 8x squared minus 34x plus 8. And so these two I feel like are typical binomial times binomial. On the third one, what happens is I have various variables here and nothing actually combines. So I end up with 4 terms in the end, 2 terms from distributing through 3x, 2 terms from distributing through 7. And on the last one, again, I have multiple variables going on, but I have like terms in the middle that I can combine. X times 5y and negative 2y times x. Those are like terms here, giving me 3 terms in my final answer. So like I said, this should say day 2. We're stopping here today. And we'll talk about some kind of special things that happen with multiplication when we meet tomorrow.